Hi, welcome to Lecture 3, Partitioning-Based Clustering Methods. In this lecture, we're going to introduce concepts and most popular methods for partitioning-based clustering. The first is we want to introduce what are the partitioning algorithms. Then we will introduce one of the most popular clustering methods called k-means clustering. Then we will discuss how to initialize k-means clustering. As alternatives of k-means methods, we are going to introduce k-medians clustering, k-medians, and k-most clustering methods. Finally, we are going to introduce the kernel k-means clustering method. So first, we will introduce basic concepts of partitioning algorithms. The partitioning method is essentially to discover the groupings in the data. That means you get like a k groups if you want to partition them into k groups by optimizing a specific object function, for example, sum of the square distance. And then we iteratively improve the quality of such partitioning. So the k partitioning method is we partition a data set D of n objects into a set of k clusters. Then we definitely can iteratively improve it so that an object function is optimized. For example, the object function could be the sum of the square distance is minimized, where C sub k is the centroid or medoid of cluster capital C sub k. So a typical objective function is sum of square arrows, is often written as SSE. So a clustering, for the SSE is sum of k clusters. K is from 1 to k. Then for each such cluster, if an object I is in this cluster, then the square arrow, this simply says the distance of sum of these squares. These such distance, the whole function is a k clusters, and each cluster gets its points to its center, the sum of such square distance or square arrows. We want to minimize this objective function. Then in general, what we can think, conceptually we can think of this. If you get a very nice k cluster, then all the objects to the center is somehow shorter. If it's shorter, then the sum of the square distance or square arrows actually will be pretty small. That's why we can get within the cluster center, the sum of the square arrow is pretty small. Then if we get a k such thing, we add them together, the whole thing will be smaller. For the k partitioning method, essentially the problem is given a k, the number of clusters, we want to find a partition of these k clusters that optimize the chosen partitioning criteria, for example, the sum of square distance. However, to find a global optimal, actually we need to exhaustively enumerate all partitioning because the potential number of partitioning actually is exponential. So more realistically, we should get a heuristic methods. That means the greedy algorithms. For example, the typically used like a k-means, k-medians, k-medians, and all the other methods are greedy algorithms or heuristic methods to find such a nice partition.